Okay, so for 3-8, slopes of parallel and perpendicular lines, this builds off of 3-7, where we talked about equations of lines. So remember, 3-7 was pretty much a review of Algebra 1. Now we're bringing equations of lines into geometry with parallel and perpendicular lines. So one very important thing about parallel lines in the coordinate plane and their slope, they have equal slopes, okay? So if two lines have the same slope, then the lines are parallel, okay? So if they have the same m right here, then they have the same slope. It might be always better to make sure you are in y equals mx plus b form to double check that the slopes are the same before confirming that they are parallel. Secondly, so that one's pretty easy if they have the same slope. For example, I have y equals 2x plus 5 and y equals 5. I didn't write the same slope. Sorry about that. 2x plus 7, okay? Then they are parallel. Parallel. Okay? So that is very important to acknowledge right there because they have the same slope. Now, if this was written in a different way, maybe it had y minus 2x equals 7, just know we could switch that to this form and to see, because if we just look at it like this, we're like, oh, -2, that's not the same slope. But when I add this to the other side, I can see that those two are the exact same lines. So it's important to have it in y equals mx plus b form so we can see what our m is. Next up, perpendicular line slope. So the slope's product, which is multiplication, equals -1. Okay, so what that means is that they are negative reciprocals of each other. So to find the slope of a line perpendicular to a given line, take the negative reciprocal of the slope. So for example, I'm going to use the same one, the y equals 2x plus 5. If I wanted the line that was perpendicular to this, my slope, so my current slope is 2, my perpendicular slope would be, I flip the fraction and change the sign. So 2 is always technically over, any number is always over 1. So I could flip that fraction and do -1/2 and change the sign. So that would be my new slope. Now problems might ask a slope and it passes through this point. So then I just use point slope form from here and I go y minus y1 equals my new perpendicular slope, parentheses x minus, turn to plus x1. So that would be the slope of the line that is perpendicular to this line and passes through this point. Okay, that's really all there is to know about slopes in parallel and perpendicular lines. Just know you flip the fraction. So if my slope is -3/5, the perpendicular slope would be +5/3. I flip the fraction and change the sign. And we can double check that because if I multiplied these two together, -3/5 times 5/3, well, that's -15/15. Any number divided by itself is 1, and that's negative right there, so it'd be -1, and the product is -1. So that's how we know that to be true. Let's look at some example problems. So we can check if lines are parallel by checking the slope, okay? So we find the slope of each line. Now you may be like, but these look parallel. Well, after we find the slope of y minus over x minus x on both of these lines, you have to find the slope on both these lines, especially if you're doing textbook problems. You have to actually write out what the slopes are. And then we can see that these aren't actually parallel. They don't have the same slope. So that's very important. And this is, like I said, slope of the line parallel to this. So we use that same slope, m equals 3, and we use that point. And then we just use point slope form. That's my answer. That's all I have to do, okay? For perpendicular lines, we need to find each slope, check if they are negative reciprocals, but double check that they multiply to be -1, okay? But you can usually observe it just from after we find the slopes of y minus y over x minus x. we can see that this is negative 3/2, and if I flip that fraction and change the sign, it'll be positive 2/3. So we can say they are parallel because the product of their slopes is -1, or we could say that their slopes are negative reciprocals of each other. So that's a very important thing to note. On the problems, like I said, you need to make sure you are writing out what the slopes are. And that's what 3-8, slopes of parallel and perpendicular lines, is all about.